Okay, so this law is a raised to power m whole raised to power n is actually equal to a raised to power m n. A raised to power m n means the powers have been multiplied m into n, keeping base as a. Here m and n are integers, they can be positive, negative or 0. So let's see through the example how we can solve the question based on it. So we have 5 raised to power 3 whole 2, or we can say 5 raised to power 3 power 2. So it becomes, we keep base as 5 and then we multiply the powers, that is we multiply 3 and 2, we get 6. So 5 raised to power 6 will be the answer of this question. We can sometimes leave our answer as 5 raised to power 6. We do not need to solve it in the form of multiplying it 5 by 6 times. But sometimes we have to do it. It depends on the question. Sometimes it can be in MCQ and we only have options in the exponential form. So we can leave it as it is. Sometimes we actually write the whole answer by solving this expression. Now let's see another example. 7 raised to power 1 whole 4, which means we multiply the powers and keep the base same, that is 7. So we multiply 1 into 4 to get 4. So our answer is 7 raised to power 4. We can solve 7 raised to power 4 or we can leave it as it is. Depends on what the question demands. Now we have negative powers also. So 2 raised to power minus 2 whole 2. So simply keep 2 as the base and multiply the powers, minus 2 into 2 to get minus 4. Please keep the sign as it is because it will be wrong. The question will get wrong if you change the sign in any other form or if you forget to put the minus sign here. So we get 2 raised to power minus 4 as our answer. Now 3 raised to power 4 whole minus 3. Again we keep base as 3 and multiply the powers, that is 4 into minus 3 to get minus 12. So our answer is 3 raised to power minus 12. I hope when there is a negative power, it doesn't frighten you, because there are students who get little fearful with the negative power. Only thing is you have to be a little careful with it. You do not need to miss it. Otherwise the question is entirely wrong. The answer to that will be entirely wrong and you will not get full marks for it. So otherwise solving of the negative power is similar to the way we solve the positive powers as well. Now we will see another law of. So now we come to a law where the bases are different. This law states a raised to power n into b raised to power m is actually equal to ab raised to power m, where a and b at our bases are non-zero integers. So what we do is, when we have power as the same and bases as different, we multiply the bases, that is a into b, and keep its power as in the power same as in the original expression, that is m. So we multiply a into b raised to power m to get our answer ab raised to power n. So if we have the question as 3 raised to power 2 into 4 raised to power 2, we keep the base, we note if the power is same. Yes, the power of 2 is same. We also note if the bases are different. Yes, 3 and 4 are different. So what we do is, we multiply the bases. We multiply 3 into 4 and we keep the power as 2. So we multiply 3 into 4 to get 12 and our power is 2. So our answer will be 12 raised to power 2. So this can be a law or it can be an expression which states a raised to power 0 is always 1. Please do not mistake this in any form. So whenever we have something like 2 raised to power 0, just simply write it as 1. 9 raised to power 0 as 1. 20 raised to power 0 as 1. 100 raised to power 0 as 1, and so on and so on. This means anything raised to power 0 is 1, provided a is a non-zero integer. So this is an expression or a law, but it is applicable in certain questions that will come along. That's all for today. Now we will proceed to solving questions that are based on these laws.